Welcome to the project demonstration of tongue control wireless wheelchair. So in this model we implemented the previous model into the Arduino UNO. So previously we did the project with PIC microcontroller, and now we did with this Arduino UNO board. So here the remaining inputs and outputs are same, like Hall Effect sensors are the input from this cap, and so based on this magnet motion with help of the tongue to these three Hall Effect sensors: forward motion and right motion and the left motion. So based on that input from this magnet sensor with help of the tongue motion, it will be identified with help of this Arduino UNO board, and it will take a decision and it will transmit the data using this encoder along with transmitter. So for encoding purpose we are making use HT12E, and this transmitter is a 433 megahertz frequency operated wireless communication transmitting module, and whenever it transmits the data based on the input from this magnets, and here we place the receiver same 433 megahertz frequency, and here we using the decoder IC, that's HT12D, and the decoded data nothing but when we place the magnet in middle sensor. So consider there are the 4 data bits. So in our project we are making use of 3 data bits: D0, D1, D2. So middle one is considered D0, D1 and D2. So same respective data will be decoded, and it will be informed to the, here also one more Arduino UNO is there. So the decoded data based on the conditions which we coded inside this UNO in embedded C language, it will control the vehicle direction, nothing but wheelchair direction, whether forward, left, right, with help of L293D motor driver. This green color board is a L293D motor driver. The main purpose of the L293 motor driver is we can control 2 DC motors in bidirectional manner. In the transmitter section, this 9 volts battery is the main power source to this one, and after this 7805 regulator, so we will get 5 volts, and that will be sufficient to control the whole transmitting section. And coming to the receiver section, we are going to use 12 volt 1 amp battery pack. This battery pack consists of 3 4 volt 1 amp batteries are connected in series, so we will get 12 volt 1 amp, and which is a rechargeable battery. So in order to charge the battery, so this one is a charging section. So just we need to connect the 230 volts input to this one, and connect the B to the B section here, and T to the T section. So after the connection was made successfully, just give the 230 volts input to this transformer. So there we can see the green light indication as the battery is charging now. So it will take at least 8 to 12 hours maximum, and after that time you can just switch off the charging circuits and disconnect this. So this is the on off switch. Okay, so after giving the power supply to that, so if the light is not on, LED is not on, just on this switch. Okay, and the next later on we can go on the execution. So let me show you in normal manner, then after we'll show you by mounting it on my head. So generally we need to mount this cap on your head, and the next switch on this section. Before that, transmitter section. So we need to connect this battery connector over here, right? Okay, and then switch on this switch, the transmitter section. This is the receiver section, right? Okay, so after that, show the magnet near the sensors, forward motion, and show it again, it will be off. If it doesn't off, stops, so you can show this again, then automatically stops. This is the left rotation. If it doesn't stops, show it again, stops, right rotation. Okay, so let me show you with real-time presentation. Connect the battery and then mount the cap on your face. So place the sensors near the tongue and attach this clip to your tongue. while demonstration we should check this magnet. So we'll show you that. So here we should place this magnet near to this. So if it is going backward again, right, so it's very good for the input to this Hall effect sensor. You can show that. So as we said, right, it doesn't stops, show it again, that's it, it stops again, right.